Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today you are watching another episode of Decode NCERT, and today I am going to discuss electromagnetic induction. Okay, this is also an important chapter in terms of concept building, in terms of depth. Okay, this is a very important chapter. So let's start with the chapter, but this is a small chapter, so we will finish it quicker than you can expect it, right? So first let us start with the chapter. First is in the introduction section, the phenomenon in which the electric current is generated by varying magnetic field is appropriately called electromagnetic induction. So and one more thing, if you are watching this series for the first time, there is a rule to watch this series. What is that rule? The rule is that you have to open your NCERT book and follow me along with it, okay, so that you don't miss out on anything. And this is the electromagnetic induction. This is the definition of electromagnetic induction. So please open your book if you have not yet done so and follow me through your book. The phenomena in which the electric current is generated by varying magnetic field is appropriately called electromagnetic induction. So what is that? That you can create current, you can generate current. So electric current can be generated, okay, by varying magnetic field. Okay, so if you vary the magnetic field, then electric current can be produced. This is the heart of all the electric generation production houses. Okay, be it coal engine, produced energy, or it is diesel produced energy, or it is hydroelectric power. Okay, or be it any other forms of energy, 90% except even nuclear power also. Okay, in nuclear power also, this is the core of every current producing mechanism. Okay, so this is how current is produced. We will see that in at the end of the chapter, AC generator. Okay, but electromagnetic induction, when was discovered, was neglected. Many scientists thought this is just another academic interest, and someone asked Michael Faraday that what is the application of it, what is the use of it. So he then famously replied that what is the use of a baby? Okay, what a baby can do. So basically at that point of time when Michael Faraday discovered this phenomena, this was just like a baby, small baby. So as it grows with time, it shows a lot of application. It shows it change our life, it changed how we live today, right? So that's powerful it was, right? Now there is an experiment, very important for your board exam. This diagram you have to draw, and this is the conclusion of this experiment. You remember that you have to take a magnet, you have to push it, you have to pull it, okay, and push and pull, and what is happening in this galvanometer, that is what is your observation. So it shows that the relative motion between the magnet and the coil, that is responsible for generation of electric current in the coil. So the relative motion between the magnet and the coil is producing electric current. Why so? Because the galvanometer is deflecting, right? This is the basic outcome of this experiment. There are two more experiments are there, but those two experiments are not important. You can read for academic purpose, but otherwise for exam purpose not super important. Now next is magnetic flux. Magnetic flux is same as electric flux, only thing is that we have to replace electric field with magnetic field. So magnetic flux is defined by B dot A or BA cos theta. Okay, and from here we will go to Faraday's law of induction. What is that? Faraday's law of induction states that the magnitude of induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. So basically when Faraday discovered this phenomena, there was no notion of this negative sign. This negative sign was still not discovered. Okay, so he just said that the EMF produced in the circuit. So basically when you are changing the magnetic field in that coil, there was some current produced in that coil, right? So that current is called induced current. Okay, normally there is no current, but because of the motion of the magnet, the circuit is producing some current. So that is called induced current. right? So normally you don't want to study in your home, but after watching my videos you started studying. So that is an induced study. I am inducing study into you, right? So I hope you get that. So basically what is it is saying that the induced EMF, so there is a current means there will be some voltage difference, right? So voltage difference basically equivalent to an EMF, that is a battery, right? So basically the motion of the magnet is behaving as if it is a battery, right? So battery means we generally use the term EMF. So the magnitude of the induced EMF in the circuit is equal to the time rate of change of magnetic flux through the circuit, right? And he said epsilon is the induced EMF, important term, right? Epsilon is represented the EMF and it is minus d phi b by dt. Okay, now if there are n number of turns present, so if it is, this is for only one turn, one coil, one turn, and if there are n number of turns present, then this epsilon becomes n d phi b by dt. As I said, this negative sign is not Faraday's credit. Even though they have added it to make it technically correct, this sign is not Faraday's credit. This sign comes from the next law, that is, we will see that, Lenz's law. Okay, Lenz's law and conservation of energy. This negative sign was contributed by Lenz. Okay, so when we were we were studying in your class 12, so that time it was said that first law of electromagnetic induction and second law of electromagnetic induction, or Lenz's law. First law was Faraday's law, second law was Lenz's law, and we used to study them together, and after that two laws we combine them to find the exact sign. Okay, but nowadays this is how the book is written, slightly different, approach is different, but the negative sign is coming from Lenz's law. You have to remember that. Okay, the polarity of induced EMF is such that it tends to produce a current which opposes the change of magnetic flux produced it. This is the Lenz's law. This is also very important law. So sometimes they will ask you Faraday's law and Lenz's law together. Sometimes they will only ask you Faraday's law and explain the terms. Sometimes they will ask you only Lenz's law and explain why it is related to conservation of energy. So you have to understand that, suppose in that coil and magnet experiment, when you push the magnet towards the coil, what is happening? A current is being produced, right? Now current is produced in a coil, what it will do? We already learned in the moving charges and magnetism that when there is a charge moving in a coil, it is producing a magnetic field of its own, right? So the coil which was carrying current, it will also produce a magnetic field. So that magnetic field, suppose I am pushing a magnet, a north pole, towards this coil. Okay, now this coil will also produce a pole of its own. Now what pole it will be? The pole, from according to Lenz's law, it will oppose the cause. It will oppose the cause. That means the pole which is induced in this side will also be north pole, so that this north pole will repel this north pole. So you have to, it will be harder for you to push the magnet towards the coil, right? So these two north pole will try to repel each other. In case, suppose, imaginary case, suppose there is a south pole created here. Okay, a south pole is created, not the north pole. Then what will happen? If a south pole was created, you push the north pole for some time, south pole becomes stronger, then it automatically started attracting this north pole towards it. Come here, like I say in my class, come here to a student, right? So basically, and the student said, no sir, I have not done anything. Similarly here also, the south pole, if in case, suppose I ask a student to come here and he without any resistance is come to my place, that will be a miracle, right? So similarly here also, north pole moving towards the south pole, that means it will automatically come and you don't have to spend any more energy and it will continue to produce electricity for lifetime. So that is not possible. Infinite energy out of nothing, which violates the conservation of energy. That's why Lenz's law is related to conservation of energy. So that's why it is called another word, it is a conservation of energy. It holds on to the conservation of energy. If Lenz's law was not there, then conservation of energy would have been violated. But conservation of energy, it is not possible to violate conservation of energy. So they have given this example. The North Pole is produced when you are moving the magnet towards the North Pole. So they will repel each other. And if the North Pole is withdrawing, that is, it is moving away from the coil, then you will see a South Pole here, and that time it will say ki come towards me. So basically it's like you went to a shop and you did some bargaining, and after some time you are expecting, if I go, the shop owner will call me back and I will give you the price that you wanted. Okay, so same thing is happening. Now you can actually find the direction of current by this method. How? Suppose in this case you are moving the North Pole towards the coil, right? So in that case we know that there will be induced North Pole, and the current, you can always do this thing. Okay, so if it is a North Pole, you can just bend this end of the N and you can find the direction of current in the loop, right? Similarly, if it is a South Pole, you can find the direction of current in the loop, right? So this is how you can say, okay, it is a counterclockwise or clockwise, right? Now this is one of the way to find the direction. Another important concept is this derivation. This derivation is super important. I have done this derivation in my lecture. If you have seen that, well, if you have not seen that, you can go and check it out in my electromagnetic induction Brahmastra series. So this is a basic idea that what is happening here. We have a rail, okay, and a magnetic field is coming into the paper, going into the paper, cross means into the paper, and there is another rail through which it can move. Velocity, with a velocity it is moving in this direction. So what is the induced EMF at the ends? Okay, induced EMF at both ends. Okay, so that is another part that we are trying to find out. What is the induced EMF here and here? So that is another important derivation, and the formula is epsilon is equal to BVL. So this, based on this, a lot of question comes in your PU board as a 2-mark question or 3-mark question, and derivation itself is a question, 3-mark question, and in your competitive exam 1 or 2 questions might come from this concept. So one of the concept is that the plane is flying in a magnetic field. A plane is flying in Earth's magnetic field, okay, and the wingspan is given this, the velocity is given v, the wingspan is say L, and the magnetic field is B. Then what is the induced EMF between the edges of that flight? Right, this is a flight. Even though it does not look like a flight, I cannot draw anything better than that. Okay, right. So this is the plane, and what is the EMF induced at this end? So again the formula will be BVL. Okay, clear? Now let's move on. Rest are just simple discussion, you can read them once, but not super important. Now next is inductance. So current induced, okay, is proportional to the flask, right? So from there we can define 2 quantities: mutual inductance, okay, mutual inductance, and mutual inductance when it happens, when suppose we have 2 concentric current carrying coils. Okay, one coil is say this way, another coil is through the inside. So whenever there is a current changes in the first coil, there is an induced current in the second coil. Similarly, if there is a current changes in the second coil, that is outer coil, there is a change in the current in the inner coil as well. So they actually compete against each other, they are controlling each other. So that the relationship between these 2 coils is called mutual inductance. Okay, so if you respect someone, someone also respects you, that is called mutual respect, right? Similarly, in this case they are called mutual induction. It is a constant between 2 coils. Mutual induction is constant. It depends on the shape and the size of the coil, how they are oriented, but if the orientation remains fixed, this is the formula that you can remember: mu r mu naught, that is basically mu r into mu naught, n1 is the number of turns of the first coil, into n2 is the number of turns in the second coil, pi r1 square, that is inner coil, into L. Okay, L is the length of the entire system. So based on this you can calculate the mutual inductance. Okay, but mutual inductance is important for all the competitive exam. I have not seen any questions from that in your board exam. Okay, but for board exam what is important is that this formula, epsilon is equal to m di by dt. So when you are talking about two coils and you want to know how much is induced on the second coil due to the first coil, or in the first coil due to the second coil, then you can use this formula, epsilon 1 is equal to minus di by dt. Okay, and similarly there is another thing is called self inductance. What is self inductance? Self inductance is for a single coil, only one coil is there. Okay, this coil will also try to change its own current as soon as the current is trying to pass through it. Okay, as soon as the current will try to pass through it, it will try to prevent that current because it's a coil. That is called self inductance and it is denoted by L. This has a very major role in our next chapter, alternating current, when we will discuss. The alternating current chapter is based on this inductor, is only based on this L. Okay, there are capacitor and resistor as well, but in that case whenever we say inductor, that means basically we are talking about this value L. Okay, so L is very important. The formula for L is also important. It is mu r mu naught n square AL. You have to remember this value. Okay, what else? The energy required to build up the current I is given by half Li square. So if you have a inductor, and you want to build up a current I in that circuit, so the work done that you have to do is given by half Li square. So very important. Based on that questions comes in the competitive exam. Now as I said, we will briefly discuss about AC generator. AC generator is basically there is a rotating armature. Okay, rotating coil is here and there are fixed magnet, huge magnets fixed like that, and this armature is getting rotated due to different things. For example, if you fix a blade here, okay, if you fix a blade, this is connected to some structure. If you fix a blade and that blade rotates with wind, it becomes wind turbine. Okay, if you fix a blade and that blade rotates with water, that becomes hydroelectric power. So this is how the same thing, same design can be modified into different applications, right? So hydroelectric power or wind turbine or any other turbine basically functions in this case. Now in case of coal or diesel or any nuclear power plant, what is happening is that coal is burned, and burning coal we produce steam. Okay, the water is heated using that energy and we produce steam. That steam is now channeled to rotate the motor. That is the basic principle. You cannot directly convert heat energy to electric energy. You have to convert it into some intermediate form, that is kinetic energy. Kinetic energy can be converted into electric energy. So this is the principle of AC generator. Okay, so that's how it is functioning. And there is one formula for induced EMF in an AC generator. So this is also important. NBA omega sine omega t. N is the number of turns, B is the magnetic field of the magnet that you have applied, A is the area, and omega is the angular speed of rotation. Right, so this formula you can remember. NBA maximum power obviously will be NBA omega. Okay, maximum power, because omega t is plus minus 1. So here they have denoted that NBA omega as epsilon naught. So NBA omega is the maximum power, maximum EMF generated in an AC generator. Okay, now with this we have to conclude this chapter. If you have any doubt, any questions, don't forget to mention that in the comment below. This is important chapter. A lot of formulas are there, as you have seen. Also the concept of electromagnetic induction is very interesting, and the life-changing discovery of Faraday. So I'll be back with a new chapter on Friday. Till then, bye.